let us go ahead and obviously, guys, firstly, I'm not Teacher Coco, we know that. But she does say hi anyways. It is her emoji. We are now moving on to trig. Now, there's a lot that you would have covered in grade 10 for trig. And what we're going to do is we're going to do sort of a quick recap of the theory that we have done. So I'm actually just gonna try and put as much of the theory as I can into this little block, and hopefully this is familiar to you guys, and we all know what's going on. So the first thing that we know is that in trig we have this thing. It is saw, it is ka, and it is toa. What does that mean? It means that sine theta is equal to my opposite over my hypotenuse. We know that cos theta is equal to my adjacent over my hypotenuse. And we know that tan theta is equal to my opposite over my adjacent. Now, what do we mean when we're talking about opposite, adjacent, hypotenuse? Remember, trig only works when we're in this right-angled triangle. So we need a right-angled triangle. We know our hypotenuse is always going to be the opposite side to my right angle. What we then have is we have this thing called theta, which is what we call our reference angle. And this reference angle will tell us which side is my opposite and which side is my hypotenuse. So my opposite side is going to be the side opposite this reference angle. And then the adjacent is going to be the last side. So in a triangle, you can calculate sort of these missing lengths or angles depending on how the question is set up using these trig ratios. Now, sometimes we work in the Cartesian plane. So sometimes we don't necessarily want to know opposite and hypotenuse and adjacent. Sometimes we want to know x, y, and r. So does anybody maybe want to tell me what is the rhyme or the acronym that you use to remember the ratios in terms of the Cartesian plane? I know the one I use, which I will definitely tell you guys. This is your favorite section. All students take coffee. Kanya, I think I see you smoking. No. Okay, well, my ears are fine now, so we will move on from here. All students take coffee. How? I don't have a rhyme. Let me tell you guys my rhyme. My rhyme that I learned was you are excellent. Are you excellent? Okay. So it was you are excellent, and then are you excellent. So obviously the U's is for Y, the R's is for the actual R, and then the excellent is for X, gamer mode for sure. See how I actually used to use gaming headphones to do lessons, and then I was like, this looks crazy. It literally looks like I'm streaming. I just want to see somebody who is unmuted. Can you view again? Cool. We are back. Okay, so yes, this was the rhyme that I learned to remember these ratios when we needed them in terms of the Cartesian plane. And it was super helpful because I just think these ratios are so difficult to like just memorize just like that. So now we have our main trig ratios. what you should know also, literally speed running, what you should know also is that we have inverse, the inverse of these ratios. So, yes, back to our pen. We have something that is called, hold on for me. We have something that is called cosec. We have something that, and I don't know whether to, yeah, let's go here. We have something that is called sec, and we have something that is called cotangent. Okay. Now these are literally the inverses, the cousins. I like that. These are literally the inverses of the ratios that they are below. So cosec is actually equal to 1 over sine theta. This is equals to 1 over cos theta. And this is equals to 1 over tan theta. They are literally the inverses. They are the opposites. And so if you think about what would happen, if they're also the opposites, we could also say that the opposite of sine is h over o. Or we could say it is, no, we could say it is r over y. Okay? We could say that sec is, if it's going to be the inverse of cos, we could say it is h over a, or we could say it is r over x. And with cotangent, we have the same inverse principle where it is going to be a over o or x over y. Cool. So that is that. Everything reminds me of IT. I didn't do IT, so I don't know how it relates. Okay. I'm just checking to see that I have got all of that in. Cool. Then we have what we call special angles. And I actually can't make space over here, which is crazy to me. How am I gonna do this? We'll go on the side, I guess. So we have then what we call special angles, and this is not letting me move any more to the side, which is bothering me. Okay, it's fine. Just ignore this side, guys. I'm gonna just sort of draw this little line. We have what we call special angles. I'm not sure how teacher Coco taught you guys special angles, but I learned it as sort of you draw a little Cartesian plane looking thingy, and maybe I should try using shapes, except there is no shapes, and I have no idea how to use this ruler thing. Oh, oh boy, I don't know how to do that. Okay, we're just gonna go with skew lines for now. So let me try. There we go, and there we go. What we then do is we go 2 lines, 3 lines. We say that this line over here is our 0-degree line, which makes a lot of sense. This is our 30-degree line. This is our 45-degree line. This is our 60-degree line. And this is my 90-degree line, which if you guys don't use this method, you should have already known that in the Cartesian plane, this is 90 degrees and this is 0. Now, all we have to do is draw 3 lines, and it does not have to actually be the exact measurement of 30 degrees or 45 or 60. So that's what we do there. And then what we do is, in order for us to know what these special angles are, is we sort of have to now draw or write in coordinates for every single one of them. And now I'm not gonna lie to you guys, I have not done this in a very long time. R is always 2. That's what I remember. And then we're filling in the X and Y values over here. Okay. And we start like this. So we go 1, 2, 3, No, I'm lying. We go 0, we go 1, we go 2, we go 3, and we go 4. But we don't just leave it at that. We now square root every single one. So square root of 4 is 2. Square root of 3 is root 3. Root 2 and root 1. Square root of 0 is 0. Once we've done that, then we start from the top. Now we go 0, 1, 2, 3, and 4. But remember, we're square rooting, so this is going to be 2. I'm going to root, 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 and root. Okay, so this will now sort of give you, for every type of special angle you're going to do, let's have a look at a 30-degree line. For my 30-degree angle, my x value is always going to be root 1. My y value is always going to be root 3. And my r value is always going to be 2. Our r value is 2. Oh, I don't know what I'm doing. Our r value is always going to be 2. So I don't know if I don't know if this is what you guys were taught. You can maybe use your reactions to let me know. Do you know what's going on here? Is this making sense? No, you've never seen this. This is crazy. Guys, so I see Teacher Coco. Let me maybe try and copy and paste what you may have been taught. Give me a second. You guys are not cooked. You guys will be fine. Let's see. Special angles. Let me copy and paste this. Okay, so we are going to copy. And then I don't know if I'm actually going to be able to paste this. There we go. Okay. Does this maybe look, oh, what did I do? Does this maybe look a little bit more familiar to you guys? The special angle table sort of thing? Is this what you guys have? Is this what you guys have learned? And let me just check that I've numbered my diagram correctly. Give me a second. O is gonna be, I don't know what it is that I'm looking at. Oh, I did it the wrong way around. Okay. Let us do this again. Okay, guys, what I want you to see is this is just a shorter way to do special angles. You don't have to memorize your special angles. Let me actually check in with you guys first. Do we know what are special angles? Do we know what we mean when we talk about special angles? Okay, so you guys will know that these are our special angles. It's basically 0, 30, 45, 60, and 90. Now, I know we usually focus on the 30, 45, and 60, but 0 and 90 degrees also fall in to our special angles. And now, what these special angles are is that they always are going to have the same trig ratios. And so you basically have to memorize the trig ratio for each, or all the trig ratios rather, for each one of these angles. But that's kind of crazy, right? Because each one of these angles are going to have 3 trig ratios that you must memorize. So that's kind of crazy. So what we do is we draw the special angle diagram. This is how I learned it in school, and it was super helpful for me. When you draw the special angle diagram, your R value is always going to equal to 2. Always, regardless of which special angle you're dealing with, your R value is always going to be 2. Then you start numbering your angles, okay? What we're basically trying to do is we are trying to figure out what's my X value going to be for every single angle and what's my Y value going to be for every single angle. because remember, they're always going to have the same values. So what we do is we start from the top and we go 0. What's the square root of 0? It's just 0. What is the square root of, let me just check that I'm doing this thing correctly. Yeah. What is the square root of 1? It's going to be root 1. What is the square root of 2? It's just root 2. What is the square root of 3? Still root 3. And then what is my square root of 4 over here? It's going to be 2. Yeah, that's now correct. Now we are correct. And then once you've done that bit, you start from the bottom again. You go 1, 2, 3, and remember we're always square rooting it. And I started again at 1. It's 0. It is 1. It is 2. It is 3, and then it's 4, but we're square rooting 4, which is just going to leave us with 2. So these are basically giving us the values that we are always going to have for each one of these special angles. So let's take an example, and let's say we wanted to do sine of 30. Okay, so let's say we wanted to do sine of 30. We know that sine is going to be y over r. And if I look at my 30-degree line, what I see about my 30-degree line is that my x value is root 3 and my y value is root 1. So what I'm going to do is sub in my stuff. My y value is going to be root 1, and my r value, remember, for every single one, your r value is always going to be 2. So, and oh yes, by the way, the square root of 1 is just 1. So you'll see now here we have a half, and here if you look at sine 30 degrees, it gives you a half. If you do it for every single one, and obviously now I have not done this in so long, there we go, because your square root of 1 is just 1. So yes, what does R represent? R represents the hypotenuse. So you know, in your triangle, usually we have this value representing the hypotenuse. When we're in the Cartesian plane, the R basically represents your hypotenuse. So if you think about in a Cartesian plane, what I've done here, I have this Cartesian plane and I've drawn a line. So this is going to be basically my X value. This over here is going to be my Y value. And this line that I've actually drawn is the R value. So your R value is always 2. Your X and Y values are determined by this diagram. Maybe use some reactions. Let me know, does this make a little bit more sense now? Are we following? If you're not, let's dive into some examples and see how we do. And the other thing that we didn't cover so far was our trig graphs. But I'm just going to go ahead for now and say that we do get our trig graphs. And let me try here. We do have graphs as well in trig. We have our sine graph, and so obviously it's going to be from x is equals to sine. What you should know about this is that, somebody tell me what's the interval usually of my sine graph? Helpful. Narisha, I love it. Anybody know what's the interval? Do we know what an interval is of a graph? It is 360, meaning one sort of wave in my sine graph is going to be 360 degrees. My maximum and my minimum is usually 1 for our sine graphs. We also then can have a cos graph. The cos graph, the difference, by the way, is that My sine graph starts, if we have a Cartesian plane, my sine graph starts from the middle, goes down and comes back up. Okay. My cos graph, however, if I have my Cartesian plane, my cos graph starts up and then goes down. So it almost looks like a V. Okay. That's sort of the main difference you guys should know if you're struggling to tell the difference between the two. And then we have our tan graph. So f of x is equals to tan x. And we know this is our really funny one. We have these little graphs that look almost disconnected from each other. Oh, I don't know if I even know how to do this anymore. I'm so bad at this, but just know I haven't. Please, let's try and draw this nicely. Do. Yeah, that's as good as I'm gonna get. Cool. So that is that. We spent quite a long time on revision, and I think I did confuse you guys with our special angles, but I just wanted to zoom out to give you guys a big picture. Oh, that's too big of a picture. Let's try that. Still too big. 65 perhaps looks a bit better. Okay. So we've covered a lot. If you're overwhelmed, it's okay. We're going to jump into questions and hopefully things will make more sense. So let us now go and let's look at some questions. Teacher Coco has prepared a really nice revision session for you guys, and she's taken questions directly out of past papers. So I'm going to do my answers on the side over here. So over here we have trig equations. Now trig equations, I know so many students get so scared by them, but they're not too different from normal equations. If you are good with normal equations, which I hope you guys are, then these equations should not scare you. The only difference is that our trig equations include, obviously, a trig ratio. But beyond that, all of our equation rules remain the same. So, by the way, if you didn't know, whenever we have a trig equation, our goal is to calculate the value of theta. It's like in a normal equation, our goal is to calculate the value of the variable. Sometimes it's x, sometimes it's a, b, whatever variable they want. So when we're doing a normal equation, what we do is we try to remove everything from the side of my variable. And I take everything over to the other side, or I do division and multiplication until I get my variable by itself. And so that's the same thing that we do when we're doing trig graphs. So right now I have, and let me go back to, let's actually do blue. Right now I have sine theta is, no, plus 0,38 is equals to 1. Remember my goal over here? My goal is to get sine theta by itself. Eventually, I just want theta by itself. But for now, if I can isolate my ratio, I will be happy. And immediately, I know my equation rule. I have a loose term over here that I can transpose. And so what's going to happen is we're going to say sine theta is equals to 1 minus 0,38. And then sine theta is going to be equal to what? Can you guys tell me what is 1 minus 0,38? 0,62. Thank you, guys. Now, when we reach this point in a trig equation, and I think I saw somebody put like a hashtag in the chat about when you're trying to do it, it's hashtag shift angle, right? So I know like immediately we want to almost divide by sine and divide by sine to get theta by itself. But what you guys should know is that sine theta does not mean sine multiplied by theta. We could only divide if the operation in between here was multiplication, but it's not. So because this is a trig ratio, there's a very special rule that we use to sort of remove the sine and the theta. And we call that arc sine. So when you want to almost transpose your ratio, you write theta, and then you have what we call arc sine. It's sine written with a -1 exponent, and you still have this angle. So what happens is whatever you had on this side will now become the angle. You plug this into your calculator and let me know what you're getting. And that is your answer. And let me actually get out the memo for this paper just so I don't have to do the calculations myself. There we go. Lieutenant, check maybe that you've put in the correct numbers. I actually perhaps think you just typed a 3 again by mistake because the rest of your numbers are right. But you guys have given me the answer in the chat very nicely. It is 38,32. And that is our answer. So I'm gonna ask you guys for your reactions again because I don't want to leave anybody behind. I want to make sure that we're all still following. How are we feeling? That was a fairly easy one, right? My bad. I figured that's what you were trying to say, Nintendo. Okay, cool. So let's try and move on to a little bit of a more difficult one. I'm going to go ahead and move this one over. Hopefully, there we go. Just so that I can continue doing the calculations here. So the next one that we have is we have two cots, and that is cotangent, in case you guys didn't know. Two cotangent, and remember cotangent is just the inverse of tan. And then we have 2 theta equals 3. Now, I always did these equations the long method because it just made more sense to me. So I'm going to show you guys what I used to do. I used to go 2, and I hate working with these ratios. So I immediately am going to say 1/10, and it is 2 theta, okay, equals 3. Immediately, I can simplify my left-hand side now. 2 times 1/10 2 theta is going to be 2 over tan 2 theta equals 3. And I can write my 3 as a fraction. When I have a fraction is equals to a fraction, I can cross, no, highlighter, I can cross multiply. So what happens is we now have 2 times 1, which is 2, is equals to 3 tan 2 theta. Remember, I want to get my ratio by itself. I'm dividing by 3 on both sides. So I basically get 2 over 3 is equals to tan 2 theta. And then from there, it's a pretty normal trig equation where I have this fraction. Sorry, I just want to give myself space. And actually, I'm just going to scroll. So we now have 2 over 3 is equals to tan 2 theta. And now we can do our arctan. So arctan is equals to 2 over 3. And that is going to be equal to 2 theta. Remember, this over here is my whole angle. My whole angle is 2 theta. So I'm not going to sort of divide by 2 or anything before I get rid of my ratio. Because when we have sort of an angle that is not just theta but is multiplied by something, I can't divide immediately like on the top by 2 to get rid of the 2 in the middle. That is not how that works. Cool. So now that we've done that, what we're going to do is put this into our calculator. What are we getting when you put in arctan 2 over 3? What are we getting? Are we quiet because we have no idea what I just did? Nintendo, let us see, 33,69, that is correct. So 33,69 equals to 2 theta. And lastly, we're going to divide both sides by 2, and that is going to give us what? What is that going to give us? So we are going to have 16,8 is equals to theta, and that's my final answer. Oh, no, I don't know what I did. Okay. Reactions, guys, make use of them. Let me know, did this make sense? This always made the most sense to me. Even though it was a longer method, it made more sense to me. The other way you could have done it is you could have gone and you could have said, well, this is 2 cot 2 theta equals to 3. Immediately we divide by 2 on both sides. Now remember, dividing by 2 does not remove this. What it does do is remove this 2 at the end. And we get cot 2 theta is equals to 3 over 2. And then what we do is you go 2 theta is equals to, and now we could do arc cot, but our calculators, yes, our calculators do not have that function. So what we do is we just go arc tan, and then we swap. So we swap our fraction around, because remember, cot is literally the opposite. It's the inverse. So yeah, that's how that works. And then again, you'll see you're left with the same thing here. You would have gotten 2 theta is equals to 33,69. You would have divided both sides by 2, and you have gotten theta is equals to 16,8. Now, I know this method is shorter, but like it always confused me. This part here where we swapped over into from cot to tan, I was like, I don't know what's going on. And I know it's the same thing, but you know, some things just make sense to us and some things don't. So these are the two methods. I hope that we're all okay and good and happy with it. Let's do our last equation before we move on. Cool. And I actually need to zoom out. I don't even know why this is so difficult to do on the web, but it is. I'm only keeping this in case somebody like comes back and wants me to re-explain something. Uh, so okay. Uh, we're gonna go put that there. Oh, now it moves more to the side. Lovely. There we go. Select. Move this entire thing. Where did it go? Sorry. I'm so chaotic today. It look like I don't know even know what just happened. There we are. Back to 100%. And to our last equation. So this one, again, not too difficult. We're following the same principles of equations. You guys must know, though, our angles, this is now my whole angle. It's cos of an angle, meaning this 3 theta minus 60, that's all one angle. It's always the last thing we want to deal with. I can't go and transpose the 60. I can't go and divide by 3. I can never deal with the angle until I've got only my ratio and my angle. So immediately, what's the first thing we're going to do to solve this equation? I'm actually not going to do it for you guys. I want you guys to tell me what's the first step we are going to do. Come on, guys. You guys are all writing. I expect us to at least have an idea of the first step we would take in our exams. Even if it's wrong, I want to know your wrong answer so I can put you back on the correct path. Great. We're going to divide by 2. Narisha and Theo, Busisi, you guys are So correct. So immediately I have 2 cos, and that is 3 theta minus 60 equals to 1,71. I cannot divide by 3. I cannot transpose the 60 because it's all inside that angle in the ratio. So the only thing I can do is divide by 2 on both sides. And what happens is my multiplication by 2 at the beginning there and my division by 2 cancel out on this side. And I'll be left with cos 3 theta minus 60. And that is going to be equals to, I get you. I am also tired. I get it. 1,71 divided by 2. What am I getting? What are you guys getting? I have the answer. Let's see, what are you guys getting? I literally am calculating with you guys. I have my calculator in front of me. 0,86. Great, but let's not round off for now. There's only 3 decimals. So let's keep it at 0,855 and see what happens. We'll round off in our last step. And now immediately, you guys, when you only have your ratio with the angle, this is now when you can do your hashtag shift angle. Okay, so we are now going to be left with 3 theta minus 60 is equals to r, of course, and my angle is now 0,855. Cool. We now have that. What are we getting when we put that into our calculators? And I'm also calculating right along with you guys. Shift cos. Okay, I have my answer. Theo beat me and is very correct. 31,24. There. So, no, and that's 3 theta minus 60. And now, basically, theta is our variable. Theta is our x. Normal equation rules. Now, we can transpose our 60. So let's do that. We go 3 theta equals 31,24 plus 60, which is going to be 91,24. Now, how do we get theta by itself? What's the next step? How do I solve for theta? The last step to finish it off. Divide by 3 to the model 100%. We are dividing by 3 on both sides. Theta is equals to what? 30,41. And I don't know why it's not letting me write. Hello. 30,41. There we go. Again, let's make use of some reactions. I had a hand. Does anybody have a question? If you guys have questions, please, please, please do ask. I'm just gonna move this to the side in the meantime, and hopefully it doesn't go crazy like it did last time. And I go down with it. Yeah, I'm gonna drop it here. Nope, it dropped right on top of this one. Okay, I think just work with me here. There we go. I honestly don't know where that is, but whatever. Cool. So those are equations. Now we're going to move on to this question that I see all the time and that I see students getting wrong all the time as well. So here it's where they give you a ratio. They give you the answer to the ratio. They told you that sine, oh, and that's too much highlighter. They've told you sine theta is equals to 4/5. Immediately what I want you guys to know, immediately when I get these questions, I go sine, cos, tan. I go you are excellent, are you excellent. Immediately I know if sine theta is equals to 4/5, that means my y value is 4 and it means my r value is 5. And now they said tan theta is less than 0. Guys, I don't know why you guys get so scared by things like this. All they're telling you is this ratio exists in a quadrant of the Cartesian plane where tan is going to be less than 0, meaning negative. So let's draw our Cartesian plane. Tan, by the way, is y and x. So in order for us to have a negative, we basically need to have a negative x or a negative y. So it can either be in this quadrant or in this quadrant, but I need to have a positive sign, meaning I need to have a positive y value. Okay, so stay with me. Stay with me. Tan is negative in this quadrant and in this quadrant. And it is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, tan is going to be negative. Tan is negative here, and tan is also negative here. So I could draw my diagram in any one of these quadrants, but they've given me a positive sign ratio, meaning that my y must be positive. My y is a positive 4. So I actually need to draw this in a place where my y value is going to be positive. And that is in quadrant number 2 over here. I'm checking in with you guys again. Are you following how I picked which quadrant to draw this little diagram in? Okay, great. Tan is a negative in the third quadrant. It is because my x is negative in the third quadrant. My x would be negative. Oh, no, you're right, because it's a negative y and a negative x. Thank you, Abu. I actually didn't realize that. You're so correct. So immediately, it would have only given us the second quadrant to do this in. No, but actually not. Tan would then be negative when we have so this is a negative x. So when we have a positive x but a negative y. So tan would have been negative in our fourth quadrant. Okay. So Tirimalo, when you get these questions, okay, they're giving you a ratio. Because they are giving you a ratio, you can sort of identify which letters you've been given. Now, it sort of comes with a lot of practicing past papers to recognize that whenever you have to do these questions, you have to draw a diagram in your Cartesian plane. Okay? So whenever you see them giving you a ratio with the actual fraction of that ratio, I want you to know you have to draw the diagram of this triangle or of the diagram in the Cartesian plane. Now, what they've said is they've told me that my sine is going to be 4 over 5. I know the ratio for sine is y over r, which basically means I can come to the conclusion that y is going to be equals to 4 and my r is going to be equals to 5. Are you with me there, Tidimalo? Cool. Now what we have to do is, remember, I have to draw a diagram to show this triangle. And we're going to do it in the Cartesian plane. Now they've given us extra information and they said that tan theta is less than 0. In other words, what they mean is that tan theta is negative. So what they're saying is I have to draw this diagram in the quadrant of the Cartesian plane where tan is going to be negative. Now for tan to be negative, I need to have a negative y and a positive x, or a positive y and a negative x. And that happens either in quadrant 2 or in quadrant 4. Tirimalo, use your reactions. Let me know again. You're following up to there? Cool. So I could have picked either one of these two quadrants, but because they told me that my sign over here was equals to 4 over 5, that's a positive sign, right? So it means I also have to pick the quadrant where my sign or my y is positive. And that happens in quadrant 2 over here. In quadrant 4, my y is negative, so it's not going to work over there. So I'm not going to use that quadrant. I am going to use my second quadrant to draw my diagram. Are we all with me? I know Tirimala only asked the question, but I know somebody was lost. So give me some reactions. Are we all with me? Cool. So what I'm going to do is I'm going to draw a triangle. You draw a triangle in your second quadrant. And basically what happens is they've given us our y value, which is going to be 4. They've given us our r value. And remember, our r value is this hypotenuse. And now we need to be able to calculate this x value. And how do we do this? By the way, this was 5. How do we calculate what our x value is? Can anybody take a guess and maybe let me know? 100%. We can use Pythagoras. We have a right angled triangle with a missing length. We know 2 of the 3. It means we can use Pythagoras. So what I'm going to say is that if my Pythagoras theorem says that r squared is equals to x squared plus y squared, and remember, always give a reason when you use Pythagoras, what's going to happen is my r is my 5, my x is what I'm trying to figure out, and my y is 4. Oh, it is 4. So expand out your exponents over here. We get 25 is equals to x squared plus 16. Transpose my 16, it will become 25 minus 16, which is what? Somebody tell me, 25 minus 16, what are we getting? I'm trying to move this. Thank you. 9, thank you. I know it was like the easiest sum on the planet, but I just want to make sure you guys are still following. Okay. Oh no, I didn't move something. Yep. Okay. This was 25 is equals to x squared, and this was squared, and this was squared. Cool. Now that we've got that, it is 25 minus 16 is going to give us 9. So 9 is equals to x squared. We're going to square root. And basically what happens is that we get that 3 is equals to x. But what I want you guys to know is the square root of 9 is not only 3. The square root of 9 is actually plus minus 3. Okay? And because of the quadrant that we've chosen, our x has to be negative. Look at which side of the x-axis we're on. We're on the side where x is negative. So actually, I'm going to pick my answer as negative 3. Okay? Are we all with me there? Do we all understand why I put the side in as negative 3? Now, I want you to know that the length of your side is going to be 3, but the actual x value we're going to have here, if we look at the coordinate point, it's going to be negative. So this is this length over here. It's 3 units, but it's on the negative side. So if I wanted the actual point, it was going to be negative. Cool. Now that we have that, I basically know that in this scenario that they've given me, my y value is equals to 4 because they've given me that. My r value is equals to 5 because they've given me that. And I now just calculated that my x value is going to be what? What is my x value going to be? Negative 3. It is my x value that's missing. I feel like there's maybe a mistake in this mem. Y over x. Yeah, there is. In the memo, they were calculating for y, but it is x that we were calculating for. So my value over here is going to be negative 3. Now they've asked us, this was all background work, by the way. They've now asked us, without the use of a calculator, but with the aid of a diagram, which is what we've done. We've drawn up our diagram. With the aid of the diagram, calculate what is tan theta. Now, if we wanted to do tan theta, and I'm trying not to squash everything in. So if we wanted to know what was tan theta, I know tan theta over here is y over x. Remember, this is why I drew out all of my ratios in the beginning, because I know I'm always going to need them, and it's just nice to get them out of the way in the beginning. Okay, so my tan theta is actually going to be y over x. Now, you tell me, guys, if we substitute based on the values that we know, what is tan theta going to be calculated as? It's not exactly a special angle, Navisha, because they're not asking tan of 30 or 45 or 60, but they are asking us tan of an angle that we've sort of been able to work around and calculate. So my y value, remember, Lutendo, we're putting our y value on the top. What's the y value? So you're super close. You're right. My x, I'm going to substitute in -3, which means I can just put it on the outside of my fraction, and then it's going to be 4. Okay, so that's that. 5.1.1 done. It is -4 over 3. Tan theta is equals to -4 over 3. Now, super important to note that they didn't ask you to calculate the value of theta. They asked you to calculate the value of tan theta. So you don't now have to go and do the whole shift angle thing here. You can stop at tan theta. Cool. Let me know, how are we doing on that one? Great. Now, I'm not going to do 5.1.2 with you guys just or right now, because I'm hoping that you guys already have the principle down. You're literally going to write 2 cos squared theta minus 1. You're going to substitute in the values of cos, which is x and r. It's going to be squared. You're going to calculate what that's going to give you, essentially. The next question is special angles. There you are 100% correct. Okay, so we're now going to move on to the special angles question. And basically what we do is, you see 0 is a special angle. 60 is a special angle. 45 is a special angle. Super important to know that when they say without the use of a calculator, which is what they've done, and guys, I'm just erasing. I'm erasing everything. So if you needed to take a screenshot, I hope that you did. I'm erasing everything over here because it's just taking me way too much time to move everything around. Okay, cool. So here they said simplify the following expression without using a calculator. It's so important that you guys know that you actually can't use a calculator, because when there are special angles, they expect you to know what the special angles are. So they expect you to either know this table off by heart or to know this diagram. And so literally when I get into a test and I see special angles, the first thing that I do is this. So I actually am going to just do this super quickly. Give me a second. Okay. When I get into a test and I see this, what I want to do is I immediately identify these are special angles. I draw my special angle diagram. Remember, R is always equals to 2. I'm going to draw in all my brackets. Boom, done, done. This is 30 degrees. This is 40. What am I doing? 0, 30, 45, 60 degrees, and this is 90 degrees. There we go. What we then do is we start from the top. We go 0. Square root of 0 is just 0. Square root of 1 is just 1. Square root of 2 is root 2. Square root of 3 is root 3. And square root of 4 is 2. Now we're at the bottom. We start again from 0, going upwards. 0, 1, 2. And remember to square root throughout. And our last one would have been the root of 4. But we know square root of 4 is just 2. So now I've drawn in my special angle diagram. I always draw this in at the beginning of a test. It's just easiest to sort of get it over and done with. And then whenever you find your special angle question, which you will, you can go back to this diagram. And by the way, that's 2. Cool. Now, I also want to know that my sine, cos, and tan, what was my mistake? You are excellent. Are you excellent? Lieutenant, what was my mistake? Did I miss something? 1, 2. This was root 2? 0, 1, 2. Oh, this is 3. This is 3. I see my mistake. Thank you. Was that the mistake, Lieutenant? I think so, yes. Cool. So now immediately I have cos of 0. I know cos is going to be x over r. When I have 0, my x value is 2, my y value is 0. Okay, so immediately cos of 0 is going to be x over r. My x value is 2, and my r value is also 2. We're all with me there on how I got that? Give me a thumbs up so I know we're still here. There we go. Now we're doing sine squared of 60. So I still want to get my fraction, but it's going to be squared, okay? So let's try sine of 60. Sine of 60, I know is going to be y over r. I look at my 60-degree line, my x value, and let me use green. My x value is root 2. My y value is also root 2. So if I need a sine, I'm going to have root 2 over, and r by r value is 2. I hope that we're all with me there. At any time that you get lost, feel free to stop me. This is just multiplication that we're going to carry forward. We're taking root 2 and we are multiplying it by sec of 45. But I know sec is the inverse of what? Somebody tell me. Sec is the inverse of? Oh, there we go. I'm seeing some answers in the chat. So we're saying it is cos. If you don't know, go back to our little recap thingy, Bobby. Sec is the inverse of cos. So if I want the inverse of cos, this is basically going to be r over x. I need to sub in r over x for the angle 45. So, oh no, did I just do this? Yep. Guys, this, by the way, is my 45-degree line. So let me maybe fix this. This is my 45-degree line. This is my 60-degree line. So when I substituted in here, I needed to get y, and my y is actually over here. That's going to be root 3. But luckily, my r value stays the same. Just realized. And then we have sec of 45. So my 45-degree line is this line over here. I want to substitute in the opposite of cos. So my r value is 2 always. And my x value is going to be root 2. Are we all with me in my substitution over here? How I calculated or how I figured out what these special angles are. Kia, what's wrong? Where did I lose you? Was it my mistake? I've been making a lot of mistakes today. I'm not going to lie to you guys. It's just that I really honestly haven't done trig in a while. Yeah, Dion, maybe you raise your hand and let me know. Narisha, I don't know if I'm glad to hear that. I'm glad that I'm helping you. Not glad that your teacher somehow is it. The whole thing from the start. Kia, we do have 4 minutes left. So I'm not going to explain from the very beginning, but what I will tell you is that our lessons are recorded. Go and watch it over again. Now, again, I don't know if I'm confusing you guys with this diagram. This is how I learned it, and it's truly the easiest way I have ever learned to remember special angles. If you have a different method here that you use for special angles that you are comfortable with that works, you are more than welcome to use another method. All that happens is that with special angles, there is sort of always these fixed ratios. It's always going to give you the same ratio. And so what we do is we have to memorize the ratios for special angles. But memorizing the ratios for special angles is crazy. So this diagram is a shortcut in a way, not a shortcut so much because it kind of does take long, but it's a way around having to memorize so many, because memorizing is a lot more difficult than drawing and memorizing this diagram. What we do is we draw this diagram, we draw basically one quadrant in our Cartesian plane, and we put in 3 lines. And we basically make the first line represent 0 degrees, the second one represent 30, 45, 60, and then 90. These are all our special angles. And then we say that our R value is always 2. And then we do what I was doing from the beginning. You start from the top, you number your X values 0, 1, 2, 3, 4, and you square root all of them. Then you start from the bottom for your Y values 0, 1, 2, 3, 4, and square root all. And then basically what that gives you is it gives you what your X value is for each one of your special angles, what your Y value is for each one of your special angles, and our R value is always 2. And what you do is when you get a special angle question, if they're asking you for the cos of 0, you literally go to your 0 degree line, which is over here, and we know this is our X value, this is our Y value, and this is our R value. Cos is going to be X over R. So I'm going to substitute in my X value here on the 0 degree line and my R value, which is 2 for every single one of them. And that's how I got 2 over 2, which is really just 1. For sine squared 60, it is just my square, okay? It's just my ratio squared. So I'm still substituting in Y over R for my 60 degree line, but I'm squaring it. And for sec 45, remember sec is the opposite of cos. So I substituted in R over X for my 45 degree line. I hope that helped you a little. But again, go back, watch the recording. And then guys, from here, once you've substituted in, this is where your teachers aren't going to know if you use a calculator. They will know if you use a calculator for the ratios, for the actual substitution of the ratios, because your calculator gives you a slightly different answer sometimes. But once you've actually got your substitution down, you can put this whole thing into your calculator, and you'll see that you'll get the answer of 15 over 4. I'm not going to go into how we actually calculate that, because that is obviously equations, and we're trying to focus on trig. Also, our lesson time is now done. So if you guys do have questions, you are more than welcome to stay behind at this point. I do want you guys to take a screenshot perhaps of this last question, 5.3, and see if you can try that. And then also our graph stuff, which we did not get to in this lesson. Take a screenshot of these questions, and I'll ask teacher Coco to post the memos in your Google Classroom.